Hi, my name is Johan, and today I would like to show you a demo of Bitfusion, vSphere Bitfusion, as it is called right now. Bitfusion was acquired last year by VMware. I've been following the technology for quite a while now, and I'm really enthusiastic about it. And in this demo, I want to show why I'm that enthusiastic. So what you see in the demo here is my vSphere environment. You can see the Bitfusion option in the vSphere client, and I have here a virtual machine called DL03, and DL03 is a Ubuntu virtual machine. It runs Docker with a couple of Docker images, and one of those Docker images contains my deep learning application, which I use for a lot of testing, training, verification, stuff like that, and also from a performance and benchmarking perspective. So what I would like to show first is if we go to the host and cluster section, we can see that I have the DL03 virtual machine here. It runs on one of my hosts, in particular ESXi01, and the ESXi01 doesn't have a GPU linked to it. When we look at the settings of the virtual machine, you can also see that there's no PCI or shared PCI device linked to the virtual machine. So this means there's no accelerator linked of whatsoever. Now, if we go back to virtual machine and I start my container, sign in, you can see it's a TensorFlow based container. The origin of the container is from the NGC platform, the NVIDIA Graphics Cloud platform, and it runs TensorFlow. It runs a couple of other applications, and it also runs something called a Jupyter Notebook. A Jupyter Notebook basically is an HTML5 based UI, which you can use to run and virtualize, in this case, Python scripts. So I have a couple of Python scripts and a customized Python application that I use for deep learning purposes. And this is the actual application. So if I shut down the screen, go back to the main window of the Jupyter Notebook, you can basically see that this is a bit of file system, right? And I have a Python project here, which I can open up. That was the screen you just saw before. And you can see that my kernel is starting here. And while this kernel is starting, you can go back to the actual output of the Docker container. So it's interactively started. And you can see here that a requested resource has been done to Bitfusion, actually. So I linked my kernel in the Python, in the Jupyter Notebook application to Bitfusion, which also means that if I shut down my kernel and still have the application running, so the Jupyter Notebook is still running, the container is still running, there's no kernel link to it, I don't have any link to Bitfusion anymore. And the reason, I can show that from a Bitfusion perspective as well. If I open up Bitfusion, you can see here that a couple of minutes ago I had or half an hour ago, a GPU linked. If you check out the potential clients I have, or the clients that I have with the Bitfusion client running on it called FlexDirect, I have DL03 as a virtual machine, and I have the container instance. Both currently have no GPU allocated, right? So my Bitfusion server has one GPU, but it has 0 GPUs allocated. Now if we go to the server tab in my Bitfusion environment, check what was happening in the last 5 minutes. You can still see nothing has been linked, and there's no utilization of whatsoever at this moment as either. There was a bit of a network packets that were transmitted, but I'll show in a bit why that was. Now, if I go to my GPU overview. This is the output of NVIDIA SMI. You can see it's running 41 degrees Celsius. It is 5 watts power consumption at the moment. Almost no frame buffer is allocated, so this is the physical video memory, and my GPU itself is doing nothing. There's no process currently running that's linked to the GPU. Now, if I go back to my deep learning application and I'm going to start the kernel, let's see, restart the kernel and run all. So now I am starting the kernel again. And if I go back to the previous window, open up the output of, in this case, the Docker container, you can see that the kernel was started, that at that moment, when I started the kernel, the resources from the GPU were requested. And if I now go back to the cluster, you can see here that the container instance has 1 GPU allocated. The server also has 1 of 1 allocated. Now we go back to the last 5 minutes. You can see here, there's a peak in the allocation, and in a couple of minutes, this will peak out because I have just one GPU in this server. Right. What I'll do next is go back to the actual deep learning application, which is an application used to train a deep learning model. I need to restart my kernel and run all of the cells again. What this application basically does, and let's go through all the different functions, is it connects a webcam. When that's done, it'll import Torch Vision as a module. It'll create a couple of deep learning or data categories. So those are, let's go back here. Yeah, so a couple of categories with data sets. I have my widgets, which need to be imported. Then I'll import a Torch and Torch Vision together with a ResNet 18 model. So I'm going to use a different or an existing model which is pre-trained and use my existing data sets or new data sets to add more data to the model. I'm going to start all of the widgets, load the actual training and validation UI, and finally here I have my UI. Now what I can do next is you can see here is my hand. I can now, I'm going to raise it a little bit, add more data to my data set. So my data set A has 3 categories, an ArduBoy, an ITQ avatar, and a Powerball. So if I take my ArduBoy, add it to the camera, I can add a couple of pictures, move it around a bit. I can do the same with my ITQ avatar, which is this tiny little awesome thing. And finally, take my Powerball, take a couple of pictures of this as well. Now I have more data to the data set. What I'll do now is train the model to add the data set or the data to the model. And you'll see in a bit that there's some progress here. And I'm going to train it a single epoch, which means it's a single iteration. I'll pull this data just one single time through the model. And I hope that the accuracy of the model will be higher than 0.95, which is basically 95% accuracy. That's kind of an issue with a single epoch because it's hardly enough to get a higher accuracy. The more epochs you run, the better it is for the model. Well, you can see it'll probably end around 92. Okay, so if I'm going to validate the model. I'm going to first take the ArduBoy, put it in front of the camera. You can see here at the right that the ArduBoy the model is 100% almost certain that this is the ArduBoy. So this is pretty cool, right? Object recognition recognizes the ArduBoy. Second thing, Powerball, right? So here it detects it's a Powerball. Now, last but not least, the avatar, same thing. It knows this is the avatar. Now, what I can do next, because this is intensive to the GPU, but it's not that intensive. I can show that. So you can, when I go back to the stats, you can see that there's a bit of network traffic coming through, but it's not that big, right? That's mainly because the pictures that I take are 640 by 480 in size. So they're not that big, and I had around 260 per item. So it's training with over 800 pictures. But due to the size of the pictures, it trains it pretty quickly. So you can see that the actual GPU memory that's allocated is really, really, really small. The same as the GPU usage. Now what we'll do next is go back to the application, train it again, but now increase the number of epochs to, let's say, 10, and run. So what's going to do now is run the same process over and over and over again. You see the accuracy increasing because it's a second time we're training the existing model. And if we go back to the Bitfusion overview, you can probably see in a bit that the GPU usage will be increasing. And the bigger the data set, the bigger the individual pictures in the data set. Obviously, the higher the utilization will be of both your GPU as well as your frame buffer. What I'll do to show some actual information is go back to the GPU section. And now you can see that it's utilizing 70 watts of power consumption. There's 1.3 gigabyte of frame buffer in use, and the GPU utilization is around 6% at the moment. When we refresh it, 8%, 4%, 7%, 8%. And you can see here that there's a process linked to the GPU called NV server, which is a process from Bitfusion. Right, 7%, 1%, 8%. So the RTX 6000 that I'm using here is a really powerful GPU, and it is so powerful that the workload that I'm testing it on, it hardly uses any of the resources. But it's a cool way to show how you can basically potentially utilize the Bitfusion to run a demo like this on. But you can see a little bit increasing. Data, there's some constant data running over the network, which is just hardly 15 MB, and the transmitted data is nothing. This is cool, right? If we look at the output of the interactive output in the appliance, you can also see that it's still running. The process hasn't been released. If we go back here, you can also see that it's running its 6th epoch. The accuracy is increasing, so it's 97%, which is really, really good. 98, so the higher, everything between 95 and 100% is considered to be good, but the higher the better, obviously. Let's check Bitfusion one more time. And let's check the GPU settings one more time. Yeah, it's constantly staying around 8% and in the 1.3 gigs. Cool. Well, I hope I gave you a pretty nice demo of Bitfusion and how you are able to use Bitfusion in conjunction with, in this case, a container, and specifically an application running inside the container. I think one of the misconceptions is that Bitfusion or using a GPU is always tied to a virtual machine or maybe tied to a container. But as I showed you in the application, it's not tied to any of these. It's mostly tied to the application itself. So if you start an application or start a process that needs to request a GPU from inside the application, at that moment, a request will be done to Bitfusion to get that those GPU resources. And Bitfusion can work dynamically with multiple requests. So you can request things like multiple GPUs, 2, 4. You can even request half a GPU or 4 times half a GPU. So you can still work with the power of the GPU and maybe even work distributed with distributed training, and have Bitfusion dynamically slice or spread that workload across multiple cards. And I think one of the advantages of using it like this is that you have multiple data scientists that can work together on a single platform without them all fully allocating a GPU to their own virtual machine. Cool. Well, thanks for watching this demo, and I hope to see you soon.